Okay, let's solve this problem. X minus y divided by x to power 3/4 plus x to power 1/2 and y to power 1/4. Next, multiply by x to power 1/2, y to power 1/4 plus x to power 1/4, y to power 1/2. And in denominator, x to power 1/2 plus y to power 1/2 times x to power 1/4, y to power negative 1/4. Okay, this is divided by x to 1/2 minus 2x to 1/4, y to 1/4 plus y to 1/2. Finally, done writing. So, nasty problem. You already know, nasty problems are my favorite problems. Okay, so first thing, let's write down domain. For domain, x has to be greater than 0, right? Y has to be greater than 0, and x cannot be equal y. This third condition, the first two is clear, right? And but third one, x cannot be equal y because of this one. Let's say if x is 1, we get 1 minus 2 plus 1, we get 0. So because of this third term, x cannot be equal y. Otherwise, the first one and second one, it can be equal because it's a multiplication and addition. So nothing wrong. Okay? All right. So let's start solving this problem. Let's see what we can do here. I'm going to convert this rational exponent into radicals. So this way it clearly, more clear, you can see what operation you can do. So this is going to be equal. We are getting x minus y. Here x 3/4, it's going to be x to power 3, radical degree 4, right? Plus, it's going to be degree 4, x to power 2, and times degree 4, y. Now, look here. I have x to power 1/2, and one would think I would put square root of x. But I put square root 2 over 4, which is going to be same 2 over 4, which is the same x 1/2. Why did I do that? So I will have seen this one and this one. I have radical degree 4. So therefore I wanted this one also have radical degree 4 to make my life easier to work them, right? When radicals have different degrees, it's you can't connect them, you can't do any operations because they don't communicate. Therefore, I did degree 4 x squared. Next, times, what do we have? Same way, x squared, everywhere x squared, I'm going to put 4. Degree 4 x squared times degree 4 y plus x here I don't have to change because I have degree 4, and times degree 4 y to power 2, right? I did the same change because it's 1/2. I turned to degree 4. And in denominator I have degree square root x plus square root y. A little bit later you will understand why. Unless you want it, okay, I can put it 4 and 2, and when it will be clear that we don't need that, we can always change it, right? Okay, let me write down like this for now. Times, let me shrink this a little bit so I can have space. All right, there we go. Now we have space and we put times. And we have x to power 1/4, degree 4 and x. We have y to power negative 1/4, right? So which means y to power negative 1/4 comes down. And in denominator, I will have x to power 1/2. So I put this at degree 4. Minus twice radical degree 4 x, radical degree 4 y, plus radical degree 4 y squared. Yes? Okay. This is what we have. Okay, let's move to next one. So x minus y, leave it where it is, but in denominator I'm going to take out radical degree 4 x squared. So what will I have? From this one, I will have left radical degree 4 x, right? Because I had cube 2 I took out, degree 2 I took out, I have left x and plus. So from here, radical degree 4x squared got out, so I will have radical degree 4 y. Yes? Okay. Moving to next one, times. What do we have? Here also I'm going to take radical x, radical degree 4 x, and radical degree 4 y. Why I'm taking x and not x squared? Why I'm taking y and not y squared? Because I have here degree 1. So I can't take square. But if I take square, there won't be enough. All right. So we are taking out radical degree 4 x and then radical degree 4 y. Okay? And in parentheses, I will have radical degree 4 x plus radical degree 4 y. Let me double check x, y. Yes, correct. Correct. And in denominator, we have radical degree 4 y squared. Okay, well, I just by mistake put y instead of x, but I'm not going to change because we have addition. It's not going to do anything. I'll put x squared here. It's not a big deal. Okay, times radical degree 4 of x. And in denominator, what are going to have here? This is getting interesting thing. This piece here. Look what we get. I'm getting the following here. Let me do workout here. Radical 4x squared, I can write down as radical degree 4x to power 2. At the end, I can put radical degree 4y to power 2. And in the middle, minus 2 radical degree 4x degree 4 y. And here is plus. Well, okay, you have plus there. Does it look like a squared plus b squared plus minus 2ab? Look here. This is a squared. This is minus 2ab. This is b squared. So this is going to be equal radical degree 4x minus radical degree 4y, and this is squared. Right? Okay. Let me clean this. So we get, this is staying is a common factor, but in here in parentheses we get radical degree 4x minus radical degree 4y squared. Okay. We have that. What is coming next? Let's see. We have x minus y. So far it stays there. And in denominator, what am I going to do with the denominator? Let me think about it. I have radical, oh, well, let's multiply all by each other now. And that's when we can do some changes, because separate, it's going to be difficult to do some changes. So I'm going to multiply all together. And let's see what we're going to get. X minus y, and then I'm getting x to power 4x, and then y to power y at the radical degree 4. Here we get radical degree 4x plus radical degree 4y. Okay, in denominator I get 4 square root, radical degree 4 x squared. Here I get radical degree 4x plus radical degree 4y multiply by radical degree 4y squared plus radical degree 4x squared. And what we have left? Radical degree 4x, in denominator radical degree 4y, and in parentheses radical degree 4x minus radical degree 4y, and all these squared. Okay, let's see what we are going to have. First of all, okay, this one I am not going to touch. I was thinking I can cancel this with this, and I noticed it's a x squared, so I cannot do that. That was wrong thinking. Let me see. I can cancel this. Oh, okay. I can cancel this with this one. Yes. I can cancel this one with this one. What else do we have? Blah, blah, blah. Radical x degree 4 by x. I guess I can combine these two, right? Oh, radical degree 4 and radical degree 4 is going to be, let's see, x to power 1/4 times x to power 1/4, right? It's going to be x to power 2/4, and it's going to be x to power 1/2, correct? And since x to power 2/4, this one is also same thing as x to power 1/2. So this is what I'm going to do. Beautiful operation. These two together, let me see, I'm going to change the color. This with this, I'm canceling with this. We understand? Or even without going through this operation, you could just see radical degree for x, radical degree for x, so it's going to be radical degree 4x squared. And here we have in denominator radical degree 4 from x squared. Okay, what we have left here in denominator. Okay, we have, let me write down clean. In numerator, I have x minus y. In denominator, I have this survived, y squared plus radical degree 4 x squared, and then times radical degree 4 of x minus radical degree 4 of y, and it is squared. Okay, can we do some changes? Yes, I can. This is what I'm going to do. Look here. First of all, I'm going to, at the radical degree 4 from square 2, I'm going to write down this format. Right? Remember when I said I wanted to leave it along the way it is, and then I said, okay, let me rewrite with the same radical, and if we need, we can change it. So now it's time to change it. So I'm going to write down, this is going to be radical square root x, y plus square root x. Here we have degree 4 of x minus radical degree 4 of y squared. And here x minus y, I'm going to represent as x as square root x squared minus square root y squared. Yes? Can I do that? And this is a formula, a squared minus b squared. And I will get square root x minus square root y. You see why I changed the degree here? That's the reason. And square root x plus square root y. All right. And as a result, what do we have? Canceling this with this, right? And we have square root x minus square root y. Let me write down clean. Oops. And here I have radical degree 4x minus radical degree 4y squared. Okay. Now radical degree 4 minus radical degree 5 y. Can I represent as radical degree 4 of x squared minus radical degree 4 of y squared, which is going to be same thing, degree 4 x squared minus degree 4 y squared. It's the same 1/2, right? Square root x minus square root y. And I'm going to represent as a squared minus b squared, correct? Which is going to be equal radical degree 4 of x minus radical degree 4. Let me rewrite here. It's going to be equal radical degree 4 of x minus radical degree 4 of y times radical degree 4 of x plus radical degree 4 of y. I used as a squared minus b squared. All right? Let me open this here. Degree 4x minus radical degree 4y times radical degree 4x plus radical degree 4y and divided by 4x minus degree 4y squared, which means I can cancel this square. What is this? Okay. I can cancel this square with this one, correct? And my answer will be left radical degree 4x plus radical degree 4y over radical degree 4x minus radical degree 4y. And that is going to be our answer. This is. Okay? Next problem. Okay. Moving to next problem. Question number 2. Let me use different colors, so if you want to rewind, you will see first one or second one. Is it by color? You can find it. Okay, question number 2. We have a cubed minus a minus 2b minus b squared over a. Here I have, let me see, 1 minus 1 over a plus b over a squared, and all this under square root, times a plus square root a plus b. Okay, and this is divided by a cubed plus a squared plus ab plus a squared b over a squared minus b squared, and plus b over a minus b, parentheses. All right, so and we need to simplify and calculate. This is when a is equal 23, b is equal 22. Well, if you want to plug from the very beginning 23 and 22, good luck with that. And if you figure out the answer with this, let me know also. I am not going to go that way. What I'm going to do, I'm going to simplify and then at the end plug 23 and 22. So this is the path I'm going to go. First of all, I'm going to bring numerator to common denominator, because we have here, look, we have b to a squared over a, right? Therefore, I'm going to bring to common denominator this entire numerator. And it is going to be, so since this a, so everywhere it's going to be a squared, a to power 4, right? Look, let me see if I can squeeze in. Let me do drafting here real quick. if I have a cubed minus a minus 2b minus b squared over a. So common denominator is a, which means this divided by a times a, not to this balanced fraction, by a by a by a and times a. Last one I am not touching because we have there a. So we are getting a to 4 minus a squared, right, minus 2ab minus b squared, and all this divided by a. Yes? Okay, so successfully I can clean this one since already we know. Next, I am going to bring to common denominator this piece. Since, look, let me work this out. 1 minus 1 over a plus b over a squared. Okay, and I'm bringing to, wait a minute, is this what I have? Yeah, I need to bring to common denominator. 1 minus square root, common denominator here is going to be a squared, right, which is here is a, here also a, and we will get a squared, correct, a plus b, correct, yes? Now, this I can write down, a minus square root a plus b over square root a squared, which is going to be equal 1 minus square root a plus b divided by a. And this is I'm going to bring to common denominator. Yes? Okay. So this is going to be equal we have denominator a, and here I'm getting a minus square root a plus b, right? Where from this a? Because this is 1, I am dividing by a and I'm multiplying by a, correct? And I'm getting a common denominator, a minus b. Okay, so we take in parentheses and we need to multiply also by a plus square root a plus b. Yes? A plus b. Okay, let me clean this. Okay, so dividing by, we are going to divide by, so we have 4 terms here, numerator, 4 terms. When we have 4 terms, it's literally begging to do grouping, right? Every time we have 4 terms, we are going to check for grouping. So let me see, a cubed plus a square. I take a square out. I will have a plus 1. And then ab plus a square b. I'm going to take ab out. And I will have a plus 1. Coming out nicely. And in denominator a square minus b square, I'm writing down a plus b times a minus b. And plus b over a minus b. I put this in parentheses because we have here addition, right? Okay, so from here, if I multiply this, it's going to be in denominator. Well, let's do numerator. Well, numerator is going to be the same. I'm going to keep it the same. A to 4 minus a squared. Let me see. Can I group it also? No, I can't because I have 2ab. But what I have here catching my eye, negative a squared minus 2ab minus b squared. It's like a squared plus b squared. If I put them in parentheses, and since I have negative sign in front, it's going to be all positive. Okay, this is what I'm going to do. This is negative, and in parentheses I'm going to have a squared plus 2ab plus b squared. Look what I did. Since I can't do grouping because I have here 2ab and I don't have 2 anywhere else, so I just combine this way, divided by a minus square root ab, a plus b, a plus square root a plus b. Do you see here a squared minus b squared formula? And divided by a. Oops, I forgot this one put. Okay, let me fix it. In numerator, I forgot to divide by a. Hold on. Okay. And divide by a. We use here thicker so you can see this is main division. There we go, main division line. All right, so from here, this a will be canceled with this a, right? Okay, and when we have more to come, changes, but we'll figure it out. So divide by, what am I going to do here? I'm going to combine this grouping a plus 1 times a squared plus ab and divide it a plus b, a minus b plus b over a minus b. Okay. Now, next one, what do we have here? We have here a to 4 minus a plus b squared, right? Okay, and this one, a minus square root a plus b times a plus square root a plus b. I can write down here c minus d. This is my c, this is my d. This is my c, this is my d, and I will have c plus d, which is going to be equal c squared minus d squared, correct? Which means it's going to be equal a squared and minus a plus b, because square root a plus b is going to be a plus b. Square root a plus b squared. Okay, so let me clean this. Divided by a plus 1. Here, second parenthesis, I can take out a times a. I will have a plus b. In denominator, I have a plus b times a minus b and plus b over a minus b, right? So what do we have here? A plus b will be gone with this a plus b. And what we have here, look, a to 4, a to power 4. It's, I can write down a2 to power 2 and minus a plus b squared, which is going to be a plus b to power 2. See there? It's like a squared minus b squared. So I'm going to open it as a squared minus a plus b and then times a squared plus a plus b. And we divide by, so in denominator we open a squared minus a. Okay, we don't have to open because I can cancel just like that. Yes? Okay, and dividing by, here we have a times a plus 1 over a minus b, and plus b over a minus b. And here we have equal a squared plus a plus b. So since we are doing division, since we have here common denominator, okay, well, let me dividing by common denominator a minus b. So in numerator we have a times a plus b, a plus 1, and plus b. Okay, I'm cleaning this because there is nothing in there. In denominator, it's only 1 left. Bringing in the middle, so it would be much better. Okay, and we have equal, so a squared plus a plus b, dividing by, which is a minus b comes up, and in denominator I will have a squared plus a plus b. Okay, this is gone, and all we have a minus b. Now successfully I am looking, my a was 23, b was 22, right? So we get a minus b, which is equal 23 minus 22 is equal 1, and that is going to be our answer. Okie dokie. Let me know if you like this type of problem, so I would load more such problems. Let me know either by comment or by like, so this way I will know you like this type of problems and I will load more. All right, see you in next video.